Hey, PreCalc students, this is lesson 7.A or task 7.A. It's about 7.1, that's chapter 7, section 1, the next chapter in our textbook. We're going to do some inverse trig. So to give you a quick reminder of what inverses are the set of undoing actions that reverse a function. For instance, if you look at the function I have right here, if I look at this function I have right here, that is f of x is equal to x squared plus 1. If I was to switch x and y and solve for y, I would get the undoing actions. For instance, the plus 1 would be minus 1, and the undoing of a square is technically a plus or minus square root. The problem with this inverse is that it truly wasn't a function. To be a function, it has to have a one-to-one nature originally. So if you look at this parabola and the graph of a parabola up 1, this is clearly not a one-to-one function because the horizontal line test will break that. Remember, a horizontal line test is really just a vertical line test of the inverse. If I was to take this graph and flip it over the y equal x line, that's the switching of x and y graphically, then it would have this looking shape and it wouldn't be a function. This technically is the square root graph, plus or minus. Look, it shifted what makes 0, right 1. It shifted right 1 there. Okay, so what they did with this one is they said, well, okay, let's restrict the domain. Let's take this x squared plus 1 graph and let's only use x's that are greater than or equal to 0. So for instance, it would be this part of the graph. I'm going to try to highlight it here. So just the positive part of the graph, or the right-hand side part of the parabola. And that way you can then say the inverse is just the positive square root graph, x minus 1. And that's an example of how we work a domain to restrict it so that we have a one-to-one function, and then therefore we can use an inverse. Okay? All right. If you haven't been taking notes, take notes now. Alrighty? We're doing arc sine. For whatever reason, this thing has two names, arc sine or sine inverse. Sine inverse, probably because of historically the way it was created. One part of the world was calling it arc sine, the other part was using this inverse. I believe this is more Newton notation than anything else, this -1 stuff. So let's do an inverse. Basic rule, you've done this before, switch x and y. Remember, here's your y. So we're going to switch x and y, and we're going to solve for y. Well, how do you get the sign off of it? Please don't say divide by sign. Please don't say divide by sign. That's like dividing by a square root symbol. This is a function of a bunch of different ideas and answers, a sine wave more specifically. So, way we have to do it is we need to think of it as the arc sine action on both sides. I am going to do the sine inverse or arc sine action on both sides. As you might remember with regular inverses, to come back over here, if I was to plug and chug one value, say 3, I think I can do 3, yeah, 3, check this out, I would plug it into the x squared plus 1 and you get 9 plus 1 or 10. Well, guess what happens when you do the inverse of, you switch x and y and you plug and chug the inverse answer. Excuse me, I'll say that better. Look what happens when you plug and chug the output, 10, into the inverse. You would get the square root of 10 minus 9, which is, 10 minus 1, which is 10, which is the square root of 9. And so that's positive 3. So do you see how these answers go back and forth? They go back and forth. Plug and chug a 3 to get a 10. Well, if you go back through the inverse factory, which I like to think of these functions as factory, the 10 will come out the other side as what it would have been on the input of the other one, 3. So that's a key memory that you have to make sense of this, okay? So here we go. Sine inverse on both sides. Looks like we get this kind of interesting answer, not much to it. Not much to calculate or derive. We just basically get this. The sine inverse cancels the sine action on this side. These guys are canceling actions. They're undoing actions, very much like the undoing of a square is a plus or minus square root. So we have this equation. Now, what this means is if we plug and chug an inverse value, okay, and if we plug and chug a value into this inverse function, it's going to be the idea of switching x and y. So this is why I have the sine table, and I want to emphasize in radian mode right here. So I'm just going to pick one of these thetas, but I'm not going to do, for instance, let's do this one. I'm not going to do sine of pi over 4. I'm going to go backwards. Watch. Sine of pi over 4 is, using the table, root 2 over 2. The y-coordinate on that part of the unit circle is root 2 over 2. So what happens when I plug and chug a root 2 over 2 into the inverse? It's basically going to kick out the pi over 4. It is running the table backwards. This idea, the idea of sine inverse of pi over 2 is asking, hey, sine of one of your thetas kicked out, outputted root 2 over 2. Which theta was it? That's the idea of inverses. The simplicity of it is you work the table backwards. You just work the table backwards. Now, we got a problem here. If you look at a sine wave, okay, let me see if I can draw a decent one here using the midline. That's not a very nice sine wave. Let me try that again. So if you do a sine wave, I'm going to do it this way. Okay, and I draw in, remember sometimes it's easier to draw the x-axis afterwards. If you do a sine wave, that's not a very pretty one, but you get it. There's my sine wave. My full period forward would end right about here. There it is. Okay. Now, let's look at the horizontal line test. Horizontal line test. Uh-oh. Uh-oh. Man, it breaks it all over the place. This isn't a one-to-one function, just like the parabola was not a one-to-one function. So we're going to have to restrict this domain. Most of the time, you might want to think, well, let's just use the positive ones. Let's just use all these positive ones. But check it out. I break the horizontal line test immediately right there. That's not good. That's not good at all. Okay, so what they decided, and they literally just kind of looked at this graph, and they kind of looked at the unit circle too at the same time. They noticed between these x values, if you go back a pi over 2, and you go forward a pi over 2, if you go back to these x values, then look, you have a one-to-one function on the inside, this little kind of S. I always look at it like a cool looking S. Okay. That's now your domain. So if you look at my table over here, this table is locked down to only answer questions that are in between negative pi over 2 and pi over 2. So that is our domain. Have to make sense of that. Now, you could argue that the same answer for a problem way over here on the far side, maybe over here, is the same answer as maybe it is over here, and there is trig that supports that answer. But right now, we're going to look at what happens, especially on a calculator. Okay, we've got to stick to the domain. If I punch in a calculator and say sine of something out of the sine inverse, and just so you know, the sine inverse button is on the calculator. Look over on the right, I'm circling the sine inverse. That's the second sine button. All the inverses are the second of each one of the forward functions. So if I do sine inverse as something that's out of the domain, it's going to give me an error. And that's because we picked a value that's beyond pi over 2 or left of negative pi over 2. Okay? Just try one real quick in your head. If I say sine inverse of negative pi over 6, negative pi over 6. Pause the video real quick. Think about the answer if you don't have it real quick. All right, I assume you're back and unpaused just in case and looked up the value, and we find the values right here. So this is, Dang it, I did that wrong. I totally did that wrong. I'm 10 minutes into this video, so I'm not going to start a new one. Sorry about that. Please forgive me. Maybe you caught it. If I'm going to do sine inverse, I better give it one of the sine outputs. So I was really trying to get you to do this, sine inverse of negative 1/2, to get you the answer of negative pi over 6 using the table. Sorry about that. Cosine runs the same way. Cosine runs the same way. Real quick, let's look at the domain and the issue of whether or not we have a horizontal line issue with the cosine graph. So if you look at a cosine graph, you can follow it, and they're going to restrict the domain. They decided to restrict, and they really mean this, they decided to restrict the domain just to the positive 0 to pi. So this is from x equals 0 to the x equal pi mark, and that is going to be the domain for cosine. Down here you can see I have a table. Listed. Let me see if I can scroll here. Okay, so this table shows you all the cosine functions. So without spending a lot of time on this, I just want to talk about what the idea of inverse is. Let's give a cosine inverse, and I'm going to be sure I do this right now. Answer, a cosine inverse answer. That's like the cosine theta's answer that I'm going to put in the input. So the cosine inverse, I need an output from cosine. I know I keep saying this sort of backwards, but it's really kind of makes it tricky. So let's do this. Let's take an answer. I'm just going to circle one right here. How about 1/2? So what would happen if I put a 1/2 into cosine inverse? Basically, it looks up on the table and finds what was the input. Here's kind of the question. What was the theta that had an output of 1/2? That's the idea of switching x and y. So if we look, the answer for that theta right there is this theta right here is pi over 3. And there's your answer. So that's how you do the homework problems. You basically are just going to look up the table. It shouldn't take too long. I can even do tan inverse here if I wanted to. Tan inverse is the same idea, but I need to use my big, huge table that has cosine, sine, tan, and even cotan inverse is available. Now, what's interesting is your calculator has no cotan inverse. So that's kind of a neat way to look at it. We won't tackle it in this little online world, but that's something to think about. I need to give you a problem that's a real-life problem of how this looks, okay? And I'm going to use tan inverse for this one. So let's say I had a right triangle. I'm going to do a real-world example here. Let's say I had a right triangle. Let's say I knew that the height of this right triangle, okay, is equal to, let's say, 15. And I was really curious what angle is being made. What angle is being made if I also knew that the adjacent, remember if I'm looking at that angle, this is my adjacent. So here's my height and my adjacent, and let's say the adjacent was 20. What angle is this making? What angle is this making? Well, we're going to do the SOHCAHTOA, excuse me, and I'm looking at an height here, and technically this height, don't think of it as hypotenuse, that is my opposite side. Remember, it's opposite from the angle. So then I got a statement here. Tan of some angle theta equals 15 divided by 20. So tan inverse of this, okay, tan inverse of this would be of 15 over 20 will kick out my angle answer. Now make sure you are in degree mode for these. We've had our setting set to radian for a long time. If we're doing radian, we can just look up the table answers if they're nice simple answers, which the first part of the homework is. But the Khan Academy section is problems like this right triangle stuff, which uses our inverse and gets us numbers that technically aren't on our table. 15 over 20 is not one of the answers on the tan table. So then you're going to use your calculator and use tan inverse to get this answer. Okay? I want you to try a problem and put it in the homework. What happens if you knew the hypotenuse was 25 and the adjacent was 15? What is this angle right here? Okay? That's it. Have a good one.